All right, guys, 2011, number 3. Here we go. We have a graph here, and there's no calculators. So I've got 8x cubed and sine of pi x. Those are my two functions. What I need to figure out, they're not labeled on my graph. So 8x cubed, if you recall, your basic cubic graph is the swiggle that goes through the origin. So that's what you're looking at here. So this lower function is f of x, and then the upper function, which follows the pattern of sine, starting at the origin and going up to 1, that's g of x. So just make note of that. Write an equation for the line tangent to the graph of f at x equals 1/2. So this one isn't too bad. Equation of your tangent line, here we go. Y minus f of 1/2 equals f prime of 1/2 times x minus 1/2. So first thing I need to do is find f of 1/2. So I sub that into my f of x function. And what I get, 1/2 cubed, remember when you're cubing a fraction, cube the top, cube the bottom. So you get 1/8 times 8, which is 1. Now I need f prime, which is 24x squared. I sub in 1/2. 1/2 squared is 1/4. Evaluate 24 times 1/4 is 6. And there's your equation of your tangent line. So part A, not too bad. Part B, find the area of R. Here we go. To find the area of R, I'm going to integrate top minus bottom from 0 to 1/2 because that's my x coordinate for the intercept. Looking at this question, 0 to 1/2 sine of pi x minus 8x cubed dx. Top minus bottom. My next step in this question is going to be to split the integral. Now in this case you have to split it because to integrate sine of pi x, you need to do a u substitution. However, you don't want to do a u substitution over here. You want to leave that x alone. So I split it, and I pull the 8 that's a constant out in front. Remember, when you split, your limits stay the same. U is pi x, du is pi dx. So I integrate. I have the reciprocal out in front. So 1 over pi, and then the integral of sine is negative cosine of u, and I changed my limits. If my lower limit was 0, 0 times pi is 0. If my upper limit was 1/2, 1/2 times pi is pi over 2. I changed my limits so that I could easily sub this in. Cosine of pi over 2 is 0, and then cosine of 0 is 1, but I'm subtracting a -1, so that turns into a +1. Over here, when I integrate the second part of my integral of x cubed is just x to the 4th over 4. Evaluate from 0 to 1/2, sub in, and you get your answer. Nothing too crazy there. Hopefully that went all right. For part C, write but do not evaluate an integral expression for the volume generated when R is rotated about the horizontal line y equals 1. What you need to realize, that's this line right here. So what I have is I have a rough sketch of my bounded region, not very accurate, but that's okay. And I'm rotating around y equals 1. So I draw my radius from the axis of revolution to the outer bounded region, axis of revolution to the inner bounded region. Because I'm revolving, I'm doing circles, so I need to integrate the area of a circle. I'm integrating pi r squared. However, in this case, because it's not a solid shape, I need pi, the integral of big R squared minus little r squared. So here's my setup. Volume equals pi, the integral from 0 to 1/2. To find my big radius, I'm going from the axis of revolution to the outer bounded region, 1 minus 8x cubed squared. So pi big R squared minus, and then here's my little r squared. 1 minus sine of pi x squared. Make sure you have a dx on there, and you're all set.